Hello, good evening.
Good evening.
Welcome to Fourth International Congress on Human-Computer Interaction, Optimization and Robotic Applications. FORA 2022 is organized by National Technical University, Kharkiv Polytechnic Institute from Ukraine. FORA 2022 is technically sponsored by IEEE Turkey section. Thank you for your scientific contribution and support to FORA 2022. Let's start session if you want. First paper belongs to dear Mustafa Karakoç. Are you ready to present? Dear Buğra Karakoç. Okay. He is not ready, maybe. Dear Fatih Eroğlu, are you ready to present?
Yes, I am.
Okay. If you want, you can start your presentation.
Okay, thank you.
You have 10 minutes, please, at most.
Okay. I'm trying to get my video on.
Şu an sesiniz geliyor mu benim acaba? Ben şu an çünkü sizin sesinizi duyamıyorum.
Değerli hocam, sesiniz geliyor.
Okay, shall we start?
Okay.
Okay, thank you. Can you see my presentation now?
Yes.
Okay, I'll start. My name is Fatih Eroğlu, and the title of my paper is Digital Implementation of Level-Shifted Pulse Modulation for Multi-Level Converters. I'm a research assistant in Gaziantep University. So we will start with an introduction first, and then we will examine properties of level-shifted pulse modulation, basically. Then we will go into detail of architectural design of level-shifted pulse modulation, and we will present our results, and finally we will finish with some conclusions. So multi-level converters can be used in several applications like motor drives, grid-connected renewable energy sources, high voltage DC transmission, and reactive power compensation. And there are some advantages of multi-level converters over 2 or 3 level converters, which are high power ratings can be achieved, and both fundamental and high frequency switching frequencies can be used, and DV or DT stresses can be reduced. So there are basically 3 topologies of multi-level converters. The first one is diode clamps, second one is flying capacitor, and the last one is cascaded H-bridge multi-level converter. This is the topology that we will use in our paper. So control techniques of multi-level converters recently has been changed from analog to digital operations, mostly due to ease of design and programmability, and implementation of advanced control techniques is possible in digital operations. And in digital operations, environmental conditions are not considered. And these controllers are microcontrollers, as we all know, and digital signal processors, and field programmable gate arrays, also known as FPGAs. It's hard to achieve sufficient number of output signals, which is very critical in multi-level converters. In microcontrollers. So microcontrollers are not very suitable for multi-level converter applications. And time synchronization becomes an issue in DSPs. And that's where FPGAs come into play. And so we can list the advantages of FPGAs as high processing speed, low development and prototyping costs, better harmonic performance, and being able to supply the required number of gating signals, which can be counted as the most important advantage compared to other microcontroller types. So in this paper, An FPGA-based digital implementation of level-shifted pulse modulation is proposed for single-phase 7-level cascade data bridge multi-level converters. And the main purpose is to develop an understanding on the design details, architectural design details of the FPGA implementation of level-shifted PWM. This configuration shows that the circuit diagram of single-phase 7-level cascade H-bridge multi-level converter. These are the H-bridges, and each H-bridge consists of 4 semiconductors, and those semiconductors are driven by level-shifted PWM in this paper. There are 3 main types of level-shifted PWM structures. The first one is PD PWM, also known as phase disposition PWM. As the name suggests, carriers of each H-bridge, let's call it cell, carriers of each cell is displayed vertically here, and they are in phase, as you can see in this graph. And in POD PWM, phase opposition disposition PWM, carriers of each cell are again displaced vertically, but opposite each other. And in APOD PWM, alternative phase opposition disposition PWM, carriers of consecutive cells are opposite each other, and they are, as you can see, vertically displaced as well. And APOD PWM also shows similar structures to PS PWM, phase shifted PWM. But there are 3 main types, basically. So in architectural design, FPGA implementation of level-shifted PWM is presented, and VHDL language is used to code the architectural system. And as a development board, we have used ZeBo Z7010 development board, and it includes Xilinx 7 series FPGA in it. It has a master clock of 125 MHz and 5 P-mode ports. These P-mode ports are critical in power converter structures because these P-modes has 8 data pins. Each one has 8 data pins, and those data pins in total makes 40 pins. And these 40 pins can be used to drive 10 H-bridges in multi-level system. So it's basically very possible to use, very advantageous to use FPGAs in multi-level converters. And in the architecture is composed of modules with different properties, and these modules we will investigate next. In carrier-based PWM structures, there should be a sinusoidal reference. And these references are generated by a lookup table in this paper. And these values are between plus 120 and minus 120. And it consists of 500 samples. These samples are for unity modulation index, and it should, that's why it should be multiplied by an amplitude modulation index. And for this aspect, we have used some, we have created some approach here. And for example, for an amplitude modulation index of 0.95, we have used 97, and we needed to obtain 0.95. Firstly, we multiplied 97 by 10, yes, and then we divided by 1,000. So it's very it's hard to just make the division in FPGA. That's why we have used a shorter version of division, which is shifting. Instead of dividing by 1,000, we shifted by 10 to imitate the division by 1,024. And that's the main reason we have used 97 instead of 95. So this is basically the structure of this process that I've just mentioned. In the normal process, we just multiply the value by the modulation index, which is in between 0 and 1. And for the FPGA implementation, we multiply it by the modulation index and shift it by 10 bits to obtain the final modulation index introduced sinusoidal value. So we need a clock divider module in the architecture as well to generate some sampling clocks for different modules. In this example, we created clocks for triangular carrier and sinusoidal reference modules. And as we said, the master clock frequency is 125 megahertz. And with this calculation, we need to develop some counter value to create different types of clocks. And this is the clock that we have generated for sinusoidal reference value. And similar procedure is held to generate clock for triangular carrier module as well. For the triangular carrier module, we need different approaches, but basically there are six counters in total for 3-cell case, as we just introduced in the level-shifted PWM carrier structures. And carrier are between 0 and 40 in their own regions, and 360 samples are used. We used counters instead of lookup tables here, different from the sinusoidal reference module. We increased or decreased these counter values when some limits are reached, depending on the type of level-shifted PWM. For example, this is for PD PWM. These are the initial values of the counters, and these are the initial directions of the counters. And 0 represents upward direction, an increasing counter value, let's say, and 1 represents a downward direction, some decreasing value of counters as well. So this is for PD PWM. Similar approaches are used in different types of level-shifted PWM structures. This is for POD PWM. As you can see, initial directions of carriers are changed with respect to PD PWM here. And this is for APOD PWM. Again, initial counter values and initial directions are adjusted to obtain APOD carrier signals. We need some logic generation modules, which are basically greater than comparator and less than comparator. Nothing special here. And a dead time generator module, which is very critical in power system applications. Let's say gating signals of some power semiconductors in the same leg of a cell should not be on or off at the same time, because there could be some short circuits if that's the case. That's why a dead time greater than the on-off times should be added. One cell becomes low, the other becomes high after a certain time, which is again dead time, let's say. And this procedure is the same for high to low cases as well. So a top module is necessary to combine all these VHDL modules together. And in this module, basically master clock and reset button is used as input, and gating signals that we will be used to fed the H bridges of the cascade H bridge multi-level converter are generated at the outputs. This is the general architecture of PD PWM as an example is presented. As you can see, this is the master clock and a reset button is here. Some clock divider module is here, and carriers are generated in this module. Similarly, sinusoidal references are generated in this module. After that, we compare these values, sinusoidal reference with the carriers, and then we add some dead times to obtain the final gating signals for the 7-level cascade H bridge multi-level converter. So, in result section, gating signals are generated for different LSPWM methods, and we used Vivado design suite here and the simulator of this design suite as well. And resource utilization are compared for the different level shift PWM values in terms of lookup table number, DSPs, input outputs, flip-flops, and buffers. So this is the result of the comparison in terms of resource utilization. As you can see on the lower side of the table, DSP, input, output, and buffer usage are all the same for the 3 different methods. But the difference here is that PD PWM uses less resources compared to POD and APOD PWM, let's say, in terms of lookup table and flip-flops. These differences are resulting from the initializations of the counters and direction variables that I've just mentioned a couple of slides ago. So we also have seen if we can generate the carriers and sinusoidal reference successfully. So this graph shows the PD-PVM application, and we obtained this graph from the Vivado simulator. As you can see, this is for PD-PVM, and they are all in phase, but vertically displaced, these carriers. And this is for POD-PVM. This is also the exact structure that we've used in the theoretical part of this paper. And this is also satisfactory. And the last one is APOD-PVM. Again, it's obtained from the FPGA. And this is also suits to the theory as well. So we basically successfully generated all three PVM structures in FPGA and validated in simulation. So to conclude, in this paper, an FPGA implementation of level-shifted PVM for a single-phase 7-level cascade edge bridge multi-level converter is held. And it is revealed that PD-PVM is the most advantageous in terms of resource utilization within the FPGA. And we verified the correctness of the carrier waveform successfully with the help of Vivado simulator. So these are my references, and thank you. That's the end of my representation. Okay.
Thank you for your presentation. The
Okay, thank you.
participants, do you have any question about the paper? Okay, no question. Thank you again.
Okay.
I wish you success in your career.
Okay, thank you.
Fatih Eroğlu.
Thank you.
Okay.
I will stop sharing my screen.
Okay. Dear Burak Karakoç, are you ready to present?
Okay, I am ready.
Okay, you can start your presentation if you are ready.
Okay, I will start it. Do you see my screen right?
Yes. Please, you have 10 minutes, okay?
Okay, first of all, okay. Hello everyone. Today I will talk about off-grid hybrid microgrid system with SCADA and control system structure. Before the start, I want to give short information about this study. This study is our graduation thesis for a bachelor degree and supported by the Scientific and Technological Research Council of Turkey. We do this project with team. So a team member, Ibrahim, will give information about the PLX stack section. Okay, let's start with the content. My presentation is divided into 11 sections. I give definitions such as what is microgrid, off-grid, etc. In introduction section. Afterwards, I will talk about our case scope, case motivation, and importance of study. In the next, I will give detailed and show about our off-grid hybrid microgrid system physical model. Following that, I will introduce system components and show SCADA interfaces and talk about control structure. And finally, we will look at PLX stack, results, conclusion, and future motivation. Let's move on to the introduction part. I will consider which definition of off-grid. Off-grid is that you don't have any enabled connection between electricity grids and hybrid power system. Imagine that a power systems which have different energy sources such as PV panels, wind turbines, fuel cells are called hybrid power systems. Let's talk about microgrids. Microgrids is an energy grid that have limited area consisting of distributed energy sources, batteries, and loads. On the other hand, energy SCADA, you know, SCADA means is supervisory control and data acquisition. As the name suggests, is a set of systems in which you can observe and control an energy system. So let's move on to our study scope. Our study primarily and important scope is build this system with low budget and designed SCADA system which have database that you can control and observe anywhere in the world. And the next, design this system with reliable auto control algorithm. You can't observe this system every time, so you need a auto control system for balancing electricity between resources and loads. Let's talk about our study motivation. Our primary motivation is giving a detailed study to literature and to raise global awareness about hybrid off-grid systems, which is one of the topics of the future in our world. Another thing is discover the a remote XY for learning SCADA system, drivings, and understand how system works. Last thing is discovering the control technique used for hybrid microgrid systems and decided what kind of control algorithm we need for running stable. After that, design control algorithm according to our research conclusion. Let's talk about the importance of study. In addition to the previously tried studies, physicalization of the system, use of the DC busbar, and use of the some step-down converter and some sensor elements that we design ourselves. All of these take our project one step further. Therefore, we have put forward to detailed research for off-grid hybrid microgrid system. So let's start with the structure of the off-grid hybrid micro power system. Here is our fundamental system schematic, as you can see. We have two different power sources, PV system and wind power. PV panel parameter is 20 voltage maximum value, 20 watts maximum power. Wind power is parameter is 35.5 voltage and 124.25 watts maximum power value. We also have a battery that have 12 voltage and 5 ampere per hour values. Also, we have a 5 buck converter that reduces the voltage values for charging the battery and feeding our load. We have the 1 boost converter. We have 1 boost converter that increase voltage value for discharging the battery. We have 3 different load types that we simulate farmland, such as air conditioning, water pump, and lighting. Here is a physical model. You can see the connection line to wind turbine, PV panel system, and our loads, and also electrical equipment about the measuring the volume. Other system components, we use the ACS sensor for measuring the current. Also, we design a voltage sensor, as you can see. These are measuring cable. These are data and ground cable. Those are our designed DC-DC buck converter circuits. We are using these for feeding load with acceptable voltage value. Okay. I have explained our system. Now I would like to discuss and show SCADA system. We use the remote XY for designing SCADA interface because it's a user-friendly interfaces like basic, you can see the switch, gauge for parameter. Also, we use it for controlling system remote XY because remote XY have a free web server for sending and receiving real-time data. And lastly, I will talk about the control structure. The energy from these sources is controlled by going through the system algorithm prepared for Arduino and VMOS microcontrollers. Our algorithm will be started with some definition about our sensors and some initial state of our relays. And after that, our algorithm will be started measuring the voltage and current values. And after that, it's going to determination algorithm. After this control stage, the energy is distributed to brushless DC motor, water pump motor, and LED lighting loads as the algorithm decides. In addition, when the solar panel and wind turbine are sufficient to provide energy to the loads, the battery also starts to act as a load and is charged with the energy it receives from these two sources. One of the main purposes of the hybrid energy system algorithm is to ensure the continuity of the system stability and to protect the battery condition. For this purpose, the charge level of the battery is checked frequently to avoid overcharging and undervoltage situations. Renewable energy sources are disconnected from the busbar when the battery voltage rises from average to higher voltage, so that the battery is not damaged. In this section, Ibrahim will give information about us.
And I will present about PLX stack and results. Parallax data acquisition tool, as known as PLX-Doc software, add-in as a Microsoft Excel macro, provides easy spreadsheet analysis of data collected in the field, laboratory analysis of sensors, and real-time equipment monitoring. We succeeded in building a low-budget, independent, and smart microgrid. All the figures were gathered with PLX-Doc. In the first figure, both sources and the battery is active, and the loads are fed by a PV panel with 9 watts and a wind turbine in 12 watts average. The battery is charging at around 12 watts. When it comes to the second figure, the only battery is feeding all the loads with approximately 12 watts. As could be seen in the last graph, the wind turbine is feeding loads with 16 watts, while the battery is charging around 8 watts.
In this section, I will continue. That's all for now on off-grid hybrid microgrid system. Let's talk about our conclusion. Our experimental design will be completed successfully, easily completed. And also our control algorithm is developed for our microgrid system. And thirdly, our data will be stored in PLX-Doc to visualize with Microsoft Excel successfully. And lastly, our Cicada system working stable and good for the controlling remotely. Last thing is future motivation. Our Cicada system can be improved, maybe using different type of Cicada tools. And also our physical model connect with the electricity grids. Third is maybe we can add the different type of renewable energy sources, such as fuel cell or biomass, etc. And lastly, our control algorithm may be more detailed for the stabilization. Thank you for your attention. I can take your question.
Thank you for your presentation. Dear participants, do you have any question about this article? Okay, no question. Thank you again. I wish you success in your career.
Thank you.
Dear
I will
Karakoç.
stop the screen sharing.
Okay. Next paper belong to dear Seda Güzel Aydın. Are you ready to present?
Yes, I'm here. I
Okay.
share my.
If you are ready,
screen.
you can start your presentation.
Okay. Hello everyone, I'm Seda Güzel Aydın. I am from Bingöl University. I will talk about our paper. That our paper
Sorry,
title
you
is-
have 10 minutes, okay?
Okay.
You have 10 minutes, okay.
Okay. I will talk about our paper. Our paper title is Efficient Hardware Optimization for Convolutional Neural Network. Content of my presentation is abstract and contribution of our paper. I will talk about it, and convolution neural network and convolution neural network on file programmable gate arrays, FPGAs. I will talk about some optimization methods for acceleration CNN implemented on FPGA. I will show our implementation, and then I'll conclude my presentation. FPGA-based CNN algorithm implementation has been made in our paper. CNN architecture has been developed via high-level language C. Accelerator design have been built by HLS, high-level synthesis, and we use the 32-bit floating point representation for our data. Synthesis report is created for Xilinx Zynq series for target FPGAs. By implementing the convolutional neural network architecture on FPGA platform, the implemented architecture has been tested by some optimization method to improve the throughput. The proposed design is optimized for convolutional layers. The most important contribution of our paper is to perform optimization on convolutional layer by unrolling the kernels and input feature maps and examine the effect on throughput, latency, and hardware researches. In this study, throughput is measured 15.6 gig operation per second for first convolutional layer. With the proposed method in this study, approximately 2.6 acceleration in terms of latency and throughput was achieved compared to the baseline design. CNN-based methods have presented successful results over traditional algorithms. This network considers a powerful tool in many areas, especially in image vision application. They are just adapted to numerous problems, but in early days, deep learning network research for deep learning network research aimed to design deeper and wider network to increase the accuracy of the network. By increasing the number of layers and establishing larger networks, it was possible to design network with high accuracy, but increasing the number of layers and designing larger networks has increased the workload of the platform used for the run network. In addition, the number of parameters in used networks has increased, which has increased the training and inference stage. This, in addition to success of the CNN in solving problems, caused an increase in the workload of the undesirable platforms and caused the general purpose platforms to be insufficient to operate such deep neural networks. As a consequence of the large number of parameters and computational burden of the CNN, research began to explore ways to design sparse and smaller networks using more compact and fewer parameters. But for some applications, such as virtual tracking system, mobile application, and object tracking, networks designed for real-time operations are required. However, central processing units are not much preferred for real-time application. To address these challenges, new solutions for efficient hardware implementation have been researched by researchers recently. To meet this requirement, numerous research tried to CNN to adopt high-performance devices such as graphic processing units, GPUs, and FPGA. Hardware accelerators, it is so hard to reveal the parallelism feature in CNN for real-time application that implemented on the CPU. Deep learning-based algorithms have been implemented and accelerated on GPU platform so that parallel computing capability and high memory bandwidth. Nevertheless, studies on the GPU show that GPU usually consume more power than FPGA, which make it inefficient and difficult to use in battery-powered devices. In conclusion, it can be said that the computing performance of GPU is noticeable. But on the other hand...
Heyecanlı mısın? Onu sorayım dedim.
Evet hocam. Türkçe'de devam edebilirim aslında, bir
Vallahi
sorun yok
bak,
ama İngilizce'de edebilirim.
Kızcağız bile, küçücük kızcağız bile yapıyor ona göre. Siz büyüksünüz hocam.
Peki hocam.
Ya bir tane sonuçta bir cümle hatalı gördüm konklüzyonda. Onu nasıl yapacağız?
Ne hocam tam olarak?
1.6 demişsin.
Bakıyorum hemen, açtım konferans sunumunu. Sonuçta hangi cümle?
Şu an seninle paylaşayım hemen, dur.
DD
Canlı yapıyorum, şu an düzeltiyorum.
nasıl
Ama
paylaştı?
sen göremezsin ki ya, göremezsin.
DC eşit ratio was above 1.6.
İlk senaryolar ilişkili şu 1.2 diye başlamış. O cümle yukarıya geçiyordu.
Olabilir hocam.
Burada biraz kopukluk olmuş.
Yo tamam, o 1.6 olayı var ya, onu silebilirsin. DD ise şu Onu sil hocam. Sadece in scenarios where the ratio of 1.2 dc ratio is below within 3 province.
The cooling energy losses are approaching to zero.
Hı hı.
At the same time, rho E decreases further, and the project depreciation approaches the lifespan, or depreciation does not occur.
Aynen. Reis.
Buraya azalıyor ama proje ömrüne yaklaşıyor.
Hı hı.
Ha, bu ne demek istiyor?
Yani şunu demek istiyor. Diyor ki tamam diyor. Enerjinin tamamını kullanabiliyorsun ama amortisman sürecin proje ömrüne geçiyor.
Hocam çok özür dilerim. Ben devam
Depreciation
ediyorum.
periyot var ya, amortisman.
Beraber söylemek.
Hı hı.
Zero losses approaching zero ile beraber demek lazım.
Hı hı. Olabilir.
While you are present zero,
Evet, Seda hocam siz devam edin.
Ha, tamam hocam, devam ediyorum.
Düzeltmeleri biz şey yapabiliriz.
Bir şey mi diyor?
olmadı onu.
Seda hocam devam edebiliriz.
Peki. CNN OFPGA. The FPGA implementation for CNN has concerned much regarded the consequence of its reconfigurability, high performance, and energy efficiency. The feed-forward format CNN techniques offers FPGA a certain advantage for creating highly paralleled and customized hardware circuits, but some limitation has. However, CNN's networks are computational intensive and memory intensive algorithms. So these features have bring many challenges to CNN implementation on hardware. FPGAs has some disadvantages such as limited resources and limited bandwidth. Therefore, implementation complex structure like deep learning algorithm on FPGA is so challenges problem. To address this problem, hardware optimization methods can be applied to network. Our implementation, we optimize the convolutional layers by unrolling kernel and input feature map to decrease latency and increase throughput. Baseline design is used to compare the result of the suggested design in register transfer level synthesis. Comparison is made by means of latency and throughput and research utilization. We use the high-level synthesis. Programming drawback of FPGA significantly reduced via high HLS tool using the C language. With the use of software-based languages in FPGA programming, in particular Vivado HLS tools, made them more attractive for software programmers to develop CNN on FPGA. So we use the HLS to implement CNN on FPGA. We optimize the convolution layer because the convolution layer is fundamental part of the CNNs. It has a highest computational density. Therefore, FPGA researchers are mostly used in the convolutional layer. This is the convolution operation.
Değerli hocam biraz hızlanabilir miyiz?
Package with multiple channel input. This is the pseudo-core convolution operation for CNN. We use the unrolling loop unrolling techniques, loop papelaning techniques, buffers, and 32-bit floating point number representation for data, and we use a streaming process. This is our framework for CNN accelerator. It consists of two layers. First is input layer, and the second convolutional layers. The input layers responsible for storing data in VRAM units, that's shown in here. VRAMs are the embedded block RAM on FPGA. The convolution layer is responsible for calculation. It consists of the three-part data cache unit, computation unit that consists of processing elements, and the output feature VRAM. The number of processing element units is determined by the unrolling these input features maps. This is our data cache structure. During the inference of CNNs, it's often necessary to read a large amount of data. Data access is so important in FPGA implementation of implementation of CNN on FPGA. The data feeding the parallel units should also come to these units in parallel way. So we use the buffer structure to feed the computational unit in parallel way. This is the baseline design. In this design, loops not rolled, they are unrolled. Operation occurs in sequentially. Only one multiplication and other unit used for baseline design. This is the research utilization for baseline design. The latency for baseline design is 14.6 microsecond. The baseline design uses 25 VRAMs and 5 DSP resources. Throughput is calculated 5.9 gigaoperation per second for baseline design. This is our proposed design. We unroll the kernels and input feature maps. This is the corresponding hardware architecture for the proposed design. There are N of processing elements units. This is the research utilization for proposed design. The latency is 18 microseconds. Proposed design is used 26 VRAMs and 8 DSP resurgers. Throughput is calculated 15.6 gigaoperation for the first convolution layer in proposed design. The most important contribution of our study is to perform optimization on the convolutional layer by unrolling kernels and input feature maps and examine the effects on the throughput, latency, and hardware resurgers. In this study, throughput is 15.6 gigaoperation for the first convolution layer. With the proposed method in this study, approximately 2.6 acceleration in terms of latency and throughput was achieved compared to baseline design. Thank you for attention. Can you any question?
Thank you for your presentation. Dear participants, do you have any question about the paper? Okay, no question. Thank you again. I wish you success. Next paper belongs to dear Musa Terkesh. Are you ready to present?
Yes.
Okay, you can start if you are ready. Please, you have 10 minutes.
Okay. Hello, I'm Musa Terkesh. I'm studying at Yıldız Technical University MCS program in electrical power systems. I will talk about the evaluation of the renewable use and therefore the self-consumption rates of an electrical vehicle charging station, which takes its energy from renewable technology and use energy storage systems. Also, this work has been supported by Yıldız Technical University Scientific Research Project Coordination Unit under project number 4886. I will continue my presentation as follows. Firstly, in the introduction, I will talk about the sectoral environmental policies, the share of energy generation, of electrical vehicles and charging stations, zero carbon emission targets, definition of hybrid power systems, and selected optimization tool. Secondly, in optimization inputs, I will talk about the selected parking lot, renewable energy data, the assumption for determining EV charging profile, the financial inputs, two different HPS models, cases, and steady aim. Third, in the results, I will examine the results from the two different cases. Discussion and conclusion, I will summarize the results paper in general, and in the last part, I will share off suggestion for the future. Look at the global carbon emission data published by the International Energy Agency, or IEA, for 2021. gigatons of carbon dioxide emission in the world, while there is a 0.5 gigatons of carbon emission in Turkey. Differently, in the same reports, when the distribution of carbon emission by sectors is examined, the qualified facilities have a share 29%, transportation or industry 23%, buildings 10%. The International Renewable Energy Agency compared it to the levelized cost of energy for renewable energy technologies. With the advancing technology, the different renewable technology decrease at different rates, as can be seen in this figure. Also, when the data of IEA is examined, the share of renewable energy in energy generation was reported as 29.6%. However, the energy generation shares of carbon-based power plants are still high. When the IEA's Global EV Outlook report is examined, as of 2022, the share of EVs in automobile market has reached 12%. As can be seen in the figure, the EV stock is increasing day by day, and China is still the leader. Moreover, in the same reports, it is estimated that the number of EVs will increase to 145 and 230 million by 2030, according to two different scenarios, optimistic and pessimistic. Today, there are 1.3 million public EVs, of which 30% belong to the fast charging type. Based on the IEA's Net Zero 2050 report, it is estimated that the market share of EVs will reach 88%, and the share of renewables in electricity generation will reach 81.5%. It is predicted that almost 70% of this share in renewables will belong to solar and wind. On the other hand, it is expected that investment to be made in end use, apart from electricity generation and energy infrastructure, will gradually increase. In the light of all these reports, due to the increasing demand for EV charging in the future, renewable energy needs to be integrated into a charging station. In addition, to achieve zero carbon emission targets, renewable use and therefore self-consumption rates must be increased for prosumers. In this study, except for solar panels and EVs, energy storage system or ESS and power conversion system or PCS are also included. Hybrid power system includes many innovative solutions such as the listed companies, and both ones are included in this paper. In the literature, many different programs or algorithms have been used for the technical, economic, and environmental optimization of HPS. However, in this study, hybrid optimization of multiple energy resources or Homer grid was preferred. University Electrical Electronics Faculty has been determined as the state. Although EV charging units are not currently available, the maximum number of parks, i.e. 75, has been set as the maximum limit to model the increasing EV charging. Since the roof of parking lot is 1,000 meters square and a PV capacity of 150 kilowatt has been determined by the area limitation, the still lighting of the relevant lot and cooling, which are the main inputs of the optimization, is shown. Another input of optimization is monthly renewable energy data. In context, while monthly global horizontal radiation data was obtained from the General Directorate of Meteorology, affiliated with Ministry of Environment, Urbanization and Climate Change of Republic of Turkey. Also, the clearness index was obtained from the NASA Surface Methodology Laboratory of Homer Grid. The variation and average values of the relevant parameters for the province of Istanbul are shown. The smart managed office charging profile offered by Homer Grid has been chosen because the relevant faculty demand is suitable for the commercial load profile. Then in this profile, current sales figure in Europe and Turkey were taken into account to determine the frequency of visits to charging station by EVs with different brands or models. In addition, the dominant EV and EVCS companies in the markets, current electrical power meters, average charging unit power and charging time are reflected in this profile. Alternatively, the charge time, charge energy, and daily and hourly charge variabilities left to Homer Grid's recommendation. It is also assumed that each charging unit to be installed in the relevant parking lot will charge 5 EVs. To model increased EV charging demand, the average daily EV charging station was determined as 50, 30, 45, 60, and 75. The EV charging profiles formed according to the increasing EV charging station are shown in this figure. Different financial inputs of HBS companies were determined by using IRENA and literature. In addition, considering the current tariff price of the relevant electricity distribution company, a 3-period grid tariff was created. Also, the data announced by the Central Bank of the Republic of Turkey at the end of 2021 were used to determine the average discount and inflation rates. When passing to cases, case A has been created for situations where electricity sales are not restricted and ESS isn't preferred. Then ESS was included in HBS at determining capacity limits, for example, 20, 40, 60, 80, and 100 kilowatt hour, and case B, fast format. Here to see the advantages of ESS more clearly, it is assumed that the sales of electricity to the grid is restricted. In both cases, the technical, economic, and environmental advantages of HBS have been examined due to the increasing demand for EV charging. In addition, in line with zero carbon emission targets, ESS have tried to maximize the self-consumption rates of prosumers. As can be seen from the table, the financial and environmental advantages of HBS have decreased with the increasing EV charging demand. According to OnlyGrid, with the HBS preference, even at highest charging demand, at 29.3% more economical and 40.7% more environmental friendly solutions achieve. With the increasing EV charging demand, the excess electricity generated from the PV was used to meet the demand instead of being sold to the grid. In this context, the self-consumption rate, or SCR, which is a measure of how efficient the PV is used in itself, increased by 60%, while the self-cycle rate, SSR, which is a measure of how efficient the PV is used to meet the demand, decreased by 40%. Due to this decrease in SSR, HBS amortized 2.6 years earlier. In scenarios where EV charging demand is low, with HBS, the share of renewables in meeting demand, namely renewable fraction, has increased 92%. In addition, 80.2% of the electricity grid strain was prevented. With the increasing charging demand, RF decreased by up to 51%, while the energy exchange rate decreased by almost half. This time, ESS is included in HBS at determined capacities. With the increasing EV charging demand, RF, SCR, and SSR have decreased, just like in case A. With the increase in ESS capacity in low demand conditions, RF increased up to 6%, SCR up to 5.7%, and SSR up to 7.8%. Due to this increase in SSR, HPS amortized itself up to 2.1 years late. Differently, with the increase in ESS capacity, carbon emission could be reduced by up to 30.2% in low demand conditions. In addition, the carbon emission reduction rate could be increased by up to 7.4% with the increased ESS capacity. This section summarizes the general benefits or described in the results section. I don't want to repeat the same things. Differently, according to other researchers in the literature, with the proposed approach, RF could be increased by up to 70%. Environmental pollution could be reduced by up to 42.6%. And cost, for example, cost of energy could be reduced by up to 88.2%. In future studies, individual and hybrid use of different ESS technologies or other renewable energy solutions besides PV, or regions with different climatic conditions, or the prosumer installation area boundaries included in this study, and also this study can be re-examined and evaluated from the same perspective. Thank you for listening. Any question?
Thank you for your presentation. Dear participants, do you have any question about the paper? Okay, no question. Thank you again. I wish you success, dear Musa Terkeş.
Thank you.
Dear Ramazan Aydemir, are you ready?
Yes, I am ready.
Okay. If you want, you can start your presentation.
Okay, let me 1 second.
You have 10 minutes, please.
Okay. Hi, everybody. I am Ramazan. I am master student at Yıldız Technical University. Today, I am going to present my paper about bit error rate performance, LIS-aided GFDM system. Looking at the outline, I am going to talk about these topics today. They are introduction, system model, simulation results, and constellation and feature works. In the wireless communication systems, the need for high data rates has grown exponentially in recent years, especially with the introduction of new services such as video on demand and the Internet of Things. One of the solutions supporting this new increased data rate is based on the solutions such as antenna arrays that can improve the signal-to-noise ratio and does increase the spectral efficiency. On the other hand, they may require high cost and cause high power consumption on the transmitter side. With the increase in the number of users in wireless communication, channel capacity, data rate, and efficient use of the transmission bands have become more important. Future 6G technologies currently appear to be an extension of their 5G counterparts, but the new requirements, new user requirements, entirely new applications, use cases, and new network trends, more challenging problems may arise in communication. Various methods involving large intelligent surfaces have been proposed as a solution to a problem between increasing spectral efficiency and minimizing transmission power consumption. The LIS has multiple low-cost reflector arrays and can reflect signals from the transmitter with adjustable phase shifts. LIS-equipped system benefits from ultra-reliability, high spectral and power efficiency from digital communication systems that meet the requirements of their various scenarios. On the other hand, if we look at the GFDM side, the latest wireless communication systems favor multi-carrier transmission because of its proven advantages over traditional single carrier communications in multipath fading channels. GFDM is one of the multi-carrier modulations schemes used in 5G wireless network based on filter bank approach and has high flexibility. GFDM is a waveform that has many advantages over 5G technologies, LTE-based systems, and perform better by providing lower out-of-band emissions. Because it uses only one cyclic prefix in its signal, it provides the best bandwidth utilization while also providing a low peak to average ratio. In this study, it is considered to position an LIS between the source and receiver to expand the usage network due to increasing needs of the GFDM. Using the LIS-aided GFDM-based wireless communication waveform, the system is expected to further support the quality and performance of user experience. In GFDM system, each GFDM block is made of key subcarrier and M time slot. A symbol corresponds to each carrier and each time zone. Adding a cyclic prefix to larger blocks further increases spectral efficiency while allowing efficient channel acquisition in the frequency domain. As you see on the picture, bit streams firstly comes to encoder, then mapper, and then modulator. After adding cyclic prefix, it is transmitted to receiver. For in our research, we performed the GFDM signals for two different channels. They are additive white Gaussian noise and Rayleigh fading channels. In LIS side, a wireless communication system shown figure 2 in next slide consists of the LIS system. We have a receiver called D and the base station called S is examined. In this system model, the transmission of data symbols takes place in two stages. Let's look at that. First stage H1 channel and second stage H2 channel. Firstly, base station transmit the GFDM signals to LIS. LIS takes GFDM signals, then it reflects the GFDM signals to users. The system has key subcarriers, and in the system, blocks of symbol length M are processed per subcarrier key. All received signals are assumed to be distorted by additive white Gaussian noise. Let's look at the simulation results. Firstly, GFDM system performed with the different receivers under AWGN channel assumption. As you see, increasing roll-off factors decrease the system performance. A side roll-off factor 0.1 and the other side roll-off factor 0.5. Key subcarriers amount and M time slot amount. Next page. In this figure, the figure shows the bad performance of GFDM and LIS-aided GFDM. In here, 4 reflecting elements were used for this aided GFDM system. They were performed under the Rayleigh fading channel. You can see GFDM this system has big performance than GFDM system. This aided GFDM system performed with the 2 different Roloff factors. They are 0.2 and 0.8. Here, 2 increasing Roloff factors decrease the system performance. The simulation results in this figure, figure 6, the simulation result was performed with the parameter values in the table. If the system requires work on the low SNR values, it should increase the reflecting elements in this system. You can see easily that. Tables in our table, we have these parameters. They are subcarriers, slots, pulse shaping filters, Roloff factors, modulation order, and reflecting elements. All simulations in our all simulations, pulse shaping filter is selected as RRC pulse shaping filter. Roloff factor is changing the figures according to figures. Modulation order, cyclic prefix, it is cyclic prefix length. And lastly, it is reflecting elements for this surface. Constellation and feature works. In this design system, it was preferred that MMSE receiver gives the lowest error rates at the expense of the highest complexity. In feature studies, this complexity can be reduced and a more effective system design can be considered. Also, energy efficiency is very important as 5G uses millimeter waves, which in certain scenarios are highly sensitive to environmental conditions and can only be used for transmission over short distance. For this reason, spectral efficiency and energy efficiency can be examined in a 5G system using GFDM. As a result of the performance that they obtained, it is expected that the effective use of LIS will significantly improve the quality and performance of user experience in wireless communication GFDM 5G scenarios. Finally, we also compared our results with the other paper results, especially GFDM Bayer analysis and LIS Bayer analysis. Our simulation results showed good accuracy. Thank you so much for listening to me.
Thank you for your presentation. Please pass me, do you have any question about the study? Okay, thank you again. I wish you success.
Thank you so much. You are welcome.
I think no question. Dear Mohammed, Rabea, Hashim, Eldahan, are you ready to present? Dear Fatma Doğan, are you ready to present?
Yes, I am here. Hocam ben
Evet.
Türkçe sunmam mümkün mü acaba?
Sunabilirsiniz, buyurun.
Tamam hocam, teşekkür ederim. Merhabalar. İsmim Fatma Doğan. Erciyes Üniversitesi'nde doktora öğrencisiyim. Bilgisayar mühendisliği anabilim dalından. Ankara şehrinde bina yoğunluğuna dayalı LoRa iletişiminin değerlendirmesi başlıklı çalışmamı sizlere sunacağım. Nesnelerin internetinden ilk olarak bahsedelim. Nesnelerin interneti, nesnelerin birbirleriyle haberleşerek akıllı birer nesne haline gelmesini sağlayan iletişim teknolojisidir. IoT günümüzde gözde araştırma konularındandır. Bu sebeple ağa bağlı cihaz sayısı hızla artmaktadır. Yapılan araştırmalara göre 2025 yılında ağa bağlı cihaz sayısının 75 milyar olacağı tahmin edilmektedir. Bu hızlı artış da IoT tabanlı ağ teknolojileri alanında gelişmelere ve yeniliklere neden olmaktadır. IoT iletişimi için Wi-Fi, hücresel ağlar, Bluetooth ve Zigbee gibi teknolojiler kullanılmaktaydı. Bunun yanı sıra IoT'ye özgü olarak geliştirilmiş, IoT'nin ihtiyaçlarını daha iyi karşılayan düşük güçlü, geniş alan ağı yani LPWAN teknolojileri de popülerlik kazanmıştır ve gelişme göstermektedir. Grafikte de göreceğimiz üzere güç tüketimi ve mesafe artışı grafiği görülmektedir. Burada Wi-Fi kısa mesafelerde, hücresel ağlar uzun mesafelerde iletişim kurulmasını sağlamaktadır. Ancak ikisinin de dezavantajı çok fazla güç tüketimidir. Bluetooth, Zigbee ve Z-Wave düşük güç tüketmektedir. Ancak onun da olumsuz yanı kısa mesafelerde iletişim kurulmasıdır. Ancak kısa mesafede iletişim gerektiren projelerde oldukça avantajlıdır. Burada en avantajlı aslında ihtiyaçları karşılayan teknoloji ise LPWAN teknolojileridir. Hem düşük güç tüketen hem de uzun mesafelerde etkili teknolojilerdir. LPWAN teknolojileri akıllı ev, akıllı site, akıllı tarım gibi alanlarda kullanılır ve genellikle düşük gigahertz ICM bandında çalışır. Bu başlıcaları LPWAN teknolojilerinden lisanssız bantla LoRa ve Sigfox iken lisanslı bantta Narrowband IoT en önemli temsilcisidir bu teknolojilerin. LoRa'nın en önemli özellikleri yüksek güvenilirliği, uzun mesafelerde düşük enerji tüketimi ve çok bantlı çalışabilmesidir. 433 MHz, 868 ve 915 MHz lisanssız radyo spektrum frekans bantlarında çalışmaktadır. Ve LoRa'yı diğer LPWAN teknolojilerinden ayıran en önemli özelliği ise chip spread spektrum teknolojisini kullanmasıdır. Bu teknoloji bilgiyi kodlamak için geniş band doğrusal frekans modülasyonu, cıvıltı darbelerini kullanan bir yayılım spektrum tekniğidir. Bir cıvıltı frekansı zamanla artan veya azalan sinüzoidal bir sinyale karşılık gelmektedir. LoRa mimarisi uç düğümler, gateway'ler ve ağ sunucusu ve uygulama sunucularından oluşmaktadır. Burada veri toplama ile görevli sensörleri barındıran 3 düğüm LoRa'ları gateway görevindeki LoRa'lar ile iletişim kurarlar. Gateway'ler ağ sunucusu ile uç düğüm LoRa'lar arasında bir köprü görevi görür aslında. Uç düğümlerden toplanan verilerin ağ sunucusuna iletilmesi sağlanır veya ağ sunucusundan gelen bilginin uç düğümlere dağıtılması sağlanır. Uç düğümlerle gateway arasında kullanılan iletişim LoRa iken ağ sunucusuyla gateway olan LoRa'lar arasındaki iletişim hücresel ağlar olabilir, Wi-Fi olabilir, IP tabanlı teknolojilerden biridir. Daha sonra ağ sunucusuna gelen veriler uygulama ihtiyaç halinde uygulama sunucularına dağıtılır. Benim uygulamamda, çalışmamda bina yoğunluğuna bağlı LoRa iletişimi için bir deney yaptım. Deney Ankara şehrinde yağmurlu bir havada 2 adet E22 900T22D EBITE LoRa modülü ile donatılmış 2 adet LoRa kartı, Arduino Nano kartı ile gerçekleştirilmiştir. LoRalı Arduino Nano kartları Arduino uygulama platformu kullanılarak C diliyle programlanmıştır. Toplanan verilerin düzenlenmesi için C# diliyle bir Windows form uygulaması yazılmıştır. Burada ilk resimde, üstteki resimde sabit bir konumda, binanın 8. katında sabit konumda alıcı LoRa'mız görülmekte. Alttaki resimde ise hareketli araca sabitlenmiş gönderici LoRa'mız görülmekte. Gönderici LoRa'mız belirlenen konumlara hareket ettirilerek alıcı LoRa'ya veri iletmekle görevli. İlk olarak otoparkta 50 metre mesafe var bina ile otopark arasında. Bir süre veri iletişimi test ediliyor ve daha sonra araç harekete geçiyor. Araç ile alıcı LoRa arasındaki mesafelerin tespiti ise Google Maps uygulamasından konum paylaşımı yöntemiyle belirlenmiştir, kontrol edilmiştir. Deneyde 1 kilometre mesafe için 100 metre aralıklarla konumlar belirlenmiştir. 50 metreden başlayıp 150, 250 şeklinde aralıklar, mesafeler için konumlar tespit edilmiştir. Her mesafe için aslında 2 adet konum tespit edilmiştir. Bina yoğunluğuna dayalı bir şekilde bir konum 2 veya daha az bina aralığına sahipken diğer bir konum gene aynı mesafede, diğer konum ise 2'den fazla bina yoğunluğuna sahiptir. Burada da aslında toplanan veriler görülmektedir. Yani her konum için 50 metre için 2 adet konum tespit edilmiştir. Bina yoğunluğuna dayalı şekilde. Buradan toplanan veriler alıcı LoRa'nın Arduino uygulamasında seri portunda izlenmiştir. Ve elde edilen veriler burada toparlanmıştır. Ve daha sonra C# ile kodlanmış Windows uygulamasında bu veriler tek tek analiz edilmiştir ve veri kayıpları tespit edilmeye çalışılmıştır. Bu arada her iletilen veri 254 adettir ve hepsi birden başlayıp 254'e kadar aralıksız olarak veri iletilmektedir. Bu veriler kaybolan verileri tespit edilmek için bu şekilde gönderilmiştir. Burada da sonuç alınmaktadır. 254 adet veri iletilmiştir. 250 metre için yapılan testte veri kaybı hiç yoktur. Deneylerde bir alıcı LoRa, alıcı ve gönderici olmak üzere 2 LoRa modülü kullanılmaktadır. Toplamda 6124 satır veri toplanmıştır. Burada bunları söyledik. 254 adet veri iletimi sağlanmıştır ve bu şekilde veri karşılaştırması için aynı koşullar sağlanmaktadır. Deney sonuçlarımızdan bütün verilerin sonuçları grafiğe ve tabloya yansıtılmıştır. Siyah olan çubuklar 2 ve 2'den daha az bina yoğunluklu mesafeleri göstermektedir. Bu sonuca göre 450 metre mesafede 450 metre mesafeye kadar hiç veri kaybı olmadan veri iletimi sağlanabilmiştir. 550 metre mesafede, şuradan da bakacak olursak diğer tablomuzdan, %2 kadarlık bir veri kaybı söz konusudur. Sonrasında ise 1 kilometreye kadar yine veri iletimi sinyal alınmıştır. Ancak 1 kilometre sonrasında %96 veri kaybı görülmektedir. Gri çubuklarımızda 2'den daha fazla bina yoğunluğunu göstermektedir. Burada 250 metre mesafeye kadar %100 veri iletimi sağlanırken 350 metre mesafede %4 veri kaybı görülmüştür. Ve sonrasında ise 750 metre mesafeye kadar sinyal alınmıştır. 750 metre mesafeden sonra hiçbir şekilde sinyal alınamamıştır 2'den fazla bina yoğunluğu olan mesafelerde. Ayrıca biz RSSI yani sinyal gücü verilerimizi de almıştık. İletilen veriler arasında RSSI verilerimiz de mevcuttu. Bunlar da karşılaştırıldığında yine benzer sonuçları elde ettik. Yine 2 veya daha az bina yoğunluğunda 250 metrede en yüksek sinyal, en iyi sinyal alınmıştır. 1 kilometrede en düşük sinyal alınmıştır. Yine de hani az bir sinyal alınmıştır. 2'den fazla bina yoğunluğunda ise 850 metreden itibaren 750 metreden sonra sinyal hiçbir şekilde alınamamıştır. Sonuçlar deney sonucunda dediğimiz gibi 6124 satır veri toplanmıştır ve toplanan veriler ile düşük ve yüksek bina yoğunluğuna sahip mesafeler için veri iletim oranları ve toplanan RSSI verileri ile sinyal iletim oranları değerlendirilmiştir. Test sonuçları ile LoRa modüllerinin şehir içinde, tabii bizim kullandığımız modüller için bu sonuçlar geçerli. Şehir içinde yaklaşık 1 kilometreye kadar mesafede kullanılabileceği gözlemlenmiştir. şehir içi LoRa haberleşmesinin büyük sitelerdeki binalar arası haberleşme veya asansörlerde acil durumlar için yetkili kişinin bulunduğu merkezi bir lokasyon ile haberleşme gibi projelerde etkin olarak kullanılabileceği öngörülmektedir. Gelecek çalışma için ise LoRa iletişim ağındaki düğüm sayısının artırılarak kurulacak bir LoRa ağ topolojisi ile şehir içinde LoRa üzerinden multi-hop iletimi yapılarak veri kaybı olmadan alıcı LoRa'ya veri iletilmesi için ağın optimizasyonu sağlanmaya çalışılacaktır. Dinlediğiniz için teşekkür ederim. Sorularınız varsa alabilirim.
Thank you for presentation. Dear participant, do you have any question about the study? Okay, no question. Thank you again. I wish you
Thank you.
success.
Thank you hocam.
Dear Amer Muklif Hamad, are you ready to present? Dear Serhil Ohaşli,
I am ready.
Ohashi,
I'm
are you ready to present?
Yes.
Okay, you can start if you are ready. Please, you have 10 minutes.
Okay, thank you. Dear colleagues, the topic of my presentation, measuring signal synthesis method of the basic of the triangular time pulse modulation for the control of radio technic system technical condition. The paper shows the need to improve the methods of the synthesis of the measuring signals to control the technical condition of radar system using amplitude modulation. The use of digital signals processing for the formation of amplitude pulse modulated signal with the subsequent narrowband filtering or to separate the envelope and carrier to the proposer. Two types for modulation of the time parameters of regular carrier pulses and the sustained. A method for the synthesis of measuring signals with a triangular law of modulation of time parameters of rectangular pulses with their subsequent narrowband filtering for the formation of the precisions amplitude modulated signals has been developed. This method allows the increase the accuracy of formation of parameters of the amplitude modulated signal to control to the technical conditions on the radio technic system. The current and non-traditional scientific and technical tasks of measuring technology include the development of processing method for generate amplitude modulation AM signals of the low frequency envelope and carrier to monitor the technical conditions of radio system. In practical, such methods are based in the incriminated formations of amplitude pulse modulation signal and their sequential narrowband filtering to isolate AM signal with sinusoidal equipment and carrier. These methods are much superior in the classic analog method of forming AM signal in accuracy and frequency range, but they still do not meet the requirement for the discrepancies and errors of persistence coefficient amplitude modulation in the area of its small value. Such accuracy tools is necessary in development and sensitive and errors of the high precision is instrumented and system with AM information signals, which are widely used, for example, in modern navigation system with the radio system. The method for forming precision AM signals based on binary modulation of time parameters of rectangular pulses satisfies and requirement. At the same time, this method forming AM signal does not allow provide to the required values of the coefficient to the envelope harmonics. Obviously, the coefficient of harmonics in the envelope can be reduced by other more complex laws of modulation time parameters of rectangular pulses and carrier and practical triangular trapezoidal pi step. This paper investigates the triangular laws of modulation of the parameters of rectangular pulses, which is used with the sequenced narrowband filtering from processing IM signal. The unit of sequence of binary rectangular carrier pulses is shown in Fig 1. We show the advantage of the triangular modulation of time parameters of pulses in comparisons with the non-binary. Moreover, consider the most common case where the shape in the carrier pulse can be described by an arbitrary functions. Then the impulses carrier sequence to the presented and the externally from. Let delta t determinators for the law. So for the modulations in the from delta to touch, as low the slide the modulation. Delta tau low the duration of modulation, delta tau I. The pulse position modulations low. With this in the mind, we write down system equations for the time parameters of the pulse sequence that is formed. Solving the system of the equations for the equations delta ti and delta tau, we obtain analysis of the expressions 3 and 4 shows that the 4 types of modulation in the time parameters, the carried rectangular pulses are possible. Phase modulation with a constant duration with the carrier pulses. Latitude modulation to or modulation of pulses durations with the carriers them evenly. Modulation of the carrier pulse front. And modulation of the carrier pulse cut. We write analysis expressions that describe for the triangular law of modulation of the front in the cut of the carrier pulses. For the triangular law of front modulation T touch I pulse to the carrier, we obtain delta T touch I, where delta single increase of change of the position of the front T touch I pulse carrier. The expressions for the triangular signs T2 touch I carrier pulses modulation law has a semi-I-law form in the expression. My exist substitution delta T touch I to delta T2 touch I and delta touch to delta 2 touch. For the combinations of the following calculation for the force of the collisions of the functions f from t, let the presented this way. Calculation sum as touch for which expressions is simulated after substituting equality for the T touch I from Formula 1, taken into account the ratio. After substituting expression to Formula 21, we obtain Formula 10, where we look the C. Sum S of the geometric progression, the calculation is as follows. Where gamma is lambda delta touch. Using these equations, we find 11 and 12, formula 11 and 12. After substitution expressed 11 and 12 into formula 10, we transforming, we obtain under the condition PL and gamma touch, which the increased for the generated signals we write as touch. A similar expression for the value S to touch we obtain from formula 30 after the formula replacement of the tau with the minus tau, delta with the delta to touch, and gamma with the gamma to touch. Analysis of state ratios for the Kam-Showman following uniprotected and bipolar carrier pulse the questions lead for the same IM values of the IM signal, but the bipolar carrier pulse sequence doubles and amplitude for the output signal with the same output pulse amplitude without modulation. In phase modulation, the value of the CAM and much smaller. Then in the Latissian modulation in the same time, two-way Latissian modulation provide twice to the value of the CAM. Then the modulation of the front or cut pulses of the carrier. The statement, however, is valid only for small values of modulation conference, which are proportional to the modulation conference is the time parameters of the carrier pulses with the corresponding numerical coefficients which are from the type of modulation. If CAM is not small, they are determined by more complex dependencies, but also more accurate, which they reduce the monological error, and this case for the recurrent CAM values to the time modulation parameters can be calculated in advance or with the help of the built-in microprocessor and recovered in the memory of the measure. The principles of the construction the measure CAM and M signals based on different types of triangular modulation of time parameters of the rectangular carrier pulses of is described by the generalized structural scheme of the measure based on the method of binary modulation. Approximately the same order half of the instrumental, the methodological comment of error. In the same coefficient, the harmonic of the envelope of the IM signal when using the method of triangular modulation of the time parameter of the carrier in the approximately 0.20 compared to 0.48 of the method of binary modulation. The obtains responses 6 and 30/40 responses and method synthesis of measuring signals on the basic triangular time pulse modulation for control of the technical conditions of radio equipment system. Formula 6 and 30 and 40 are also starting point on the study of the different times of modulation of time parameters of rectangular carrier pulses. In the following works of the result of research of the different types of modulation of time parameters of the rectangular pulses of the carrier will be result advanced and last such times of modulation of definite. The proposed method of the triangular modulation of the time parameters of the carrier follows but narrow band filtering provides compared of the method of binary modulation, reduction of the harmonic coefficient with the throws and about the same rendered small error of the CAM generate IM signal. Thank you for attention. Thank you.
Thank you for your presentation. Dear participants, do you have any question about the paper? Okay, no question, I guess. Thank you again. I wish you success in your career. Dear Ayşe İnan, are you ready to present?
Yes, I'm ready.
Okay, you can start your presentation. You have 10 minutes, please.
Okay. Hello, everyone. I would like to talk about EMI filter design with passive components for power line. Here the content. This content is divided into 4 main sections and their subsections. First of all, I am going to start with definition of line. It can be defined as any signal that causes a decrease in the performance of the devices, deterioration or malfunction, and it can be propagated by radiation or conduction. There are three different methods for reducing EMI. These are shielding, grounding, and the last one is filtering. Shielding consists of placing the circuit in a completely enclosed area such as metal box or covering equipment with conductors. This covering material acting as a shield against the penetration of radiation from the surface. Another method of reducing EMI is grounding. Keeping the wires as close to ground as possible reduces external inductance of the circuit or other components. And the last method is filtering. Filters can be installed in a power line of the equipment or placed on the equipment circuit board. Filtering is used to keep the noise of the signal outside the desired frequency ranges. The use of EMI filters installed in conductors is increasing day by day, due to the fact that this filter to be designed will be placed in the power line of the equipment, which has maximum power consumption of 50 watts and supplied with 28 volt DC. When we examine the working principle of the filter, the EMI filter installed in the power line of the equipment consists of passive components, inductor and capacitors. At high frequency, inductors block unwanted currents, while capacitors provide a low impedance path to divert noise from away the filter input to ground connection. And the standard that filter must comply with at this stage is MIL STD 461G. This standard defines the test limits, test levels, and the test procedure for various electromagnetic phenomena for electronic equipment used in military purpose. In this standard, electromagnetic tests are divided into 4 groups. Since we are designing a filter placed on the power line, we will examine the conducted emission tests. Here are the CE 101, 102, and 106 tests. Since we want to test our filter between 10 kHz and 10 MHz frequencies, we will examine only CE 102 tests. CE 102 test is a medium frequency voltage measurement test. The emission levels are determined by measuring the voltage present at the output port of the LASN, and the limits are based on the source voltage of the equipment. And our equipment supply voltage is 28 volt DC, so this is our test limits. We have set some requirements for the filter. One of them is electrical requirements. Maximum filter input voltage is 50 volt DC. Operating voltage of the equipment where the filter is installed, 28 volt DC. Filter output current, maximum 1.8 ampere load. Second requirement is standard requirement. We expect that compliance with CE 102 tests, and other requirements are based on commercially available filters. Our third section is filter design, and we begin with circuit design. Electromagnetic interference is divided into 2 as differential mode and common mode. Common mode noise is noise that overlaps all conductors carrying the signal in transmission line, and the differential mode noise is when noise penetrates only one point of the signal transmission line. This type of noise is reference to the system cases. And here the CX, CY, LCM, and LDM components. CX capacitors only affects differential mode noise. CY capacitors affects both, but little effect on differential mode noise. LCM inductors affect only common mode noise. LDM inductors affects both mode noise, but little effect on common mode noise. The common mode and differential mode circuits of the EMI filter used in this design are shown below. The left one is common mode circuit, and the right one is differential mode circuit. When the equivalent circuit of the noise is connected with these circuits and simplification is made, equivalent filter circuits for the common and differential mode are obtained, and the following equations were found. In order to determine the component values of the filter, reference common and differential mode noise were used, and the cutoff frequencies were determined. In order to examine the characteristics of the filter, we examined the noise values at some sample frequencies and calculated the expected suppression values here. Here we choose the CY capacitors 4.7 nanofarad and use the following formulas to determine the values of the LCM inductors and calculate it as 2 millihenry. Then apply the same procedure for CDM and LDM. After calculating their values, we put into circuits. Then we simulated equivalent common mode and differential mode circuits in LC SPICE program. Here the common mode circuit simulation and differential mode circuit simulation. We examined the frequency responses of these circuits and recorded in the suppression values at the same sample frequencies in table. After circuit design phase, it was time for PCB design. This design is performed in Altium Designer program. PCB paths have been tried to be as straight as possible. It is aimed to be reduce the inductive effects caused by the distance. And the last design section is case design. After case design in CATIA program, the isolation rings used to connection points are plastic. And the conclusion part here. It's been observed that when the filter is simulated in LT SPICE program, it suppresses the references noises at the desired level. And this simulation results show that this filter provided reduce the noise coming to the equipment to which the installed through the power line, operations of the equipment more stable, and minimize the malfunctions that may occur due to the noise in the equipment. Here are the references, and thank you very much for listening to me.
Thank you for your presentation. Dear participants, do you have a question about this article? Okay, no question. Thank you again. I wish you success in your career.
Thank you.
Dear Alparslan Demirci, are you ready to present?
Yes, I'm here.
Okay.
My name is Sait Mirza Tarzan. Mr. Demirci is not available for his sickness.
Okay, you can present.
Yes, thanks.
You have 10 minutes, please.
Okay. Can you see my screen?
Yes.
Yes. My name is Sait Mirza Tarzan. I will present our study conducted with Alparslan Demirci, Zafer Öztürk, and İsmail Nakir. My title is Determination of Photovoltaic Inverter Ratio, Minimizing Energy Clipping for Electric Vehicles Charging Station under different solar radiations. First of all, I will start with aim and importance of the study and briefly describe the modeling of load and weather data, photovoltaic panel, energy storage system, and converter efficiency, converter equations, and economic parameters and assessment criteria, and then case and results, and I will conclude the presentation. In many developed countries, RES incentives have been reduced because of the huge amount of installed capacity. Therefore, optimal sizing of power plant, considering PV panel, inverter capacity, and ESS become more important. Economic concerns also directs optimization methods to minimize investment and operation costs. DC and AC ratio is that mean power ratio of PV array and AC inverter. In US, it has been determined the 1.2 and 1.3 in our public service projects. Clipping, you can see the figure clip energy due to the lower DC-AC ratios, but DC-AC ratio can be increased to minimize cost of energy. The clipping losses can be ignored due to the decreasing PV panel model prices. We evaluate using the three Istanbul, Ankara, and Samsun. The three provinces of the Turkey have different climatic conditions, and we assume that electric vehicle charging station daily average energy demand is 1.2 megawatt hour per day, and peak demand is 128.5 kilowatts. And these are the photovoltaic equations, energy storage system and converter equations. And the assessment criteria, we select assessment criteria, the well-known cost of energy, return of investment, net present cost. And also we consider renewable fraction and excess energy. The figure shows the created hybrid power system model for electric vehicle charging station system. You see the 5 different electric vehicle charging station, totally 100 consumer potential per day. And the electric vehicle charging station connected to AC bus and the PV panel and electric energy storage system connected to DC bus. And also there was a inverter between them. We assume inflationary discount rates 7.4 and 80.5 respectively, and our project life is assumed 20 years. First of all, we use lead acid battery, and then we get the results. The results belong to Istanbul. You can see the upper yellow line to the maximum inverter capacity. According to the installed PV capacity, it is selected 300 kilowatt. And the middle yellow line, the optimal converter capacity, and the base red line, the minimum converter capacity. If we select maximum capacity, we have a lot of we increased installation cost. If we select the lower line, the red line, and namely minimum converter capacity, we have loss of clipping energy. We try to optimize, and we select 180 kilowatts for converter capacity to minimize clipping energy and maximize renewable fraction. These are the numerical results belong to the three different provinces. First, we evaluate 300 kilowatts as converter capacity for each provinces, and then we optimize them. In the proposed methodology. On the other hand, we calculate energy storage system for each scenario, and we get the results. RF, renewable fraction, and carbon dioxide emission, and clipping energy losses, and return of investment, net present cost, and the cost of energy. And you can see the energy storage system integration reduce carbon dioxide emission 5%. And the interesting result is DC-AC ratio. DC-AC ratio is sized by in PV installed power instead of optimally for each region. RF increase only up to 2%. Namely, we use this converter capacity. We can only get 2% RF increase. And the other result is clipping energy change along with net present cost and converter capacity factor. We can see this if we use the same ratio, namely DC PV power and AC inverter power is equal, we get lower Reynolds fraction, lower convert, and loss of clipping energy. If we use Istanbul for Samsung 5.7, for Antalya 3.7, and for Istanbul 4.7, we get the optimized net present cost. We summarize the results. These in the study, the effect of DC-AC ratio were examined by considering technical, economic, and environmental effects. Optimal clipping energy results were realized: 5.7 for Samsung, 4.3 for Istanbul, 3.7 for Antalya, where the ratio, DC-AC ratios are 1.6 and this respectively. If DC ratio is below 1.5, net present cost increased exponentially due to the inverter installation cost, despite the slowing of AC clipping energy losses. Net present cost varies up to 9% depending on the solar radiation of the region. If DC ratio fell below 1.2, net present cost worsens for Samsung Istanbul due to the lower solar potential. In optimal DC-AC ratio scenarios, inverter capacity factor range 20 to 24%, and also ESS integration reduced carbon dioxide emission about 5%. The clipping energy losses, clipping energy increases to 33% as DC-AC ratio approaches 3, while clipping energy decreases very little or remain constant if it falls below 1.2. Relative decrease in renewable energy incentives necessitates optimal HPC control and management. Higher solar in Antalya lead to greater clipping energy losses than other regions. It's determined that RF increases only up to 2% if DC-AC ratio is 1. Optimal result obtained for each region, for all regions, 1.3 or 1.6. It is partially improved the return of investment. In scenarios where the ratio of DC-AC ratio is 1.2 and below for 3 provinces, clipping energy losses are approaching 0. Although clipping energy losses are getting 0, return of investment further decreases and depreciation approaches project lifespan, or depreciation does not occur. Thank you for listening.
Thanks for your presentation. Dear participants, do you have any question about the article? Okay, no question. Thank you again. I wish you success in your career.
Thanks you very much.
Dear Mohammed Habek, are you ready to present?
Yes, I am sharing.
Okay, you can present your study.
Okay. Can
You
see
have
my
10 minutes,
screen?
please. Yes.
Okay, okay.
You have 10 minutes, please.
Okay. Welcome to my presentation. I am Mohammed Habek. I am a master student at Gazi University. I will talk about digital image encryption using electrical cryptography, a review. Content, it's like that. Introduction. Billions of digital images are shared on many platforms each second, especially on messaging applications and social media. However, there are many security threats such as alteration of digital images, illegal acquisition and distribution, theft or disclosure of personal data. Therefore, a need arises in security of digital images. Encryption methods are widely used to ensure the security of digital images. Digital image is basically a matrix. Considering a matrix which each row and column has a corresponding pixel value represents a digital image. Each pixel has an intensity value, and these values create the digital image. In figure 1, pixel values of red, green, and blue components are shown in a 7x6 matrix for a selected point anywhere in a color image. These are the types of digital images: binary, grayscale, and color. Binary image is represented by 1 bit. It can be 1 or 0. Grayscale image pixels can be a value between 0 and 255. Each pixel is represented by 8 bits. The image is a gray color based on each pixel value. Color image pixels can be a value according to the amount of red, green, and blue. Each of the RGB components has a value between 0 and 255, and these are 8 bits. So the color image is basically 24 bits. What is elliptic curve cryptography? ECC is a public key-based encryption method proposed by Koblitz and Miller in 1985. The reason why it is so popular nowadays is the security it provides and the short key size. Compared to RSA, which is another public key-based encryption, a very low key size is needed for the same level of security. The mathematical operations in ECC are performed on finite fields. The purpose of using finite fields is to give more accurate and efficient results. A general elliptic curve equation one, as you can see. Here, A and B and P, the user chooses. A and B are smaller integers. P, sufficiently large prime numbers. And A and B must satisfy equation 2. Elliptic curve discrete logarithm problem is the security guarantee of ECC. Actually, it is the reason of using elliptic curve in encryption. As seen in equation 3, the point Q on the elliptic curve is obtained as a result of the scalar multiplication of any point P picked on the elliptic curve and a private integer key picked between 0 to P minus 1. Even if the malicious third party knows the Q and P points, it is very, very difficult to find the private key value according to ECDLP. It lasts decades generally to find a key private key. We will talk about image evaluation parameters. Unified average changing intensity, UACI, is used to measure the average intensity of difference between two encrypted images which their plane images have 1 pixel difference. The value of UACI should be around 33%. Number of pixel change rate is defined as different pixel numbers of two encrypted images which their plane images, all pixels are same, but 1 pixel is different. The value of MPCR should be around 99%. Histogram analysis. Image histogram is a graphical representation of the distribution of image pixel values. A histogram of a plain image and a histogram of encrypted image should be totally different because the histogram of a plain image distributes non-uniformly generally. The histogram of an encrypted image should distribute uniformly. Information entropy. It is used to measure the average data of every bit in an image. Information entropy shows that potential data in an image. Every pixel value of an image differs from the others. So pixel of encrypted image that has uniform histogram have same entropy. Security attacks, we will talk about them for 6 of them. Non-plain text attack. Attack method, it is for crypto analysis that assumes the attacker has information about both plain data or original data, and it is corresponding encrypted data. With this information, the attackers are able to get information about the secret key or to develop an algorithm that can decrypt any further message. Ciphertext only attack. Method for crypto analysis assumes the attacker has the capability of to get information only from ciphertext. The attacker will be able to apply this attack when there are at least a pair of ciphertext that comes from a pair of good plain text. Chosen plain text attack. Attack for crypto analysis method which assumes the attacker has the ability to choose some plain text and view their corresponding encrypted data. The purpose of this attack to get information about secret key or to get more optimized algorithm to decrypt any further message. Brute force attack. Brute force attack is a type of ciphertext only attack. It depends on exhaustive key search to find a secret key of a crypto system. K-space. K-space is a total of all possible keys that can be used in an encryption method. Big key spaces are resistant to brute force attacks since there are a lot of possible key for encryption or decryption. Dictionary attack that uses a restricted database which is included commonly used keys since users tend to choose basic or predictable keys. We will talk about digital image encryption studies based on ECC. Double image encryption method. Two original images are converted to a compressed quantization matrix using discrete wavelet transformation. The matrices are encrypted with ECC. Images are encrypted using the algorithm with a new chaotic system. Number two, image encryption algorithm that merges ECC with Hill cipher. Hill cipher is used as an asymmetric encryption. 4x4 matrix that has inverse matrix is used as a secret key encryption. Therefore, it will not be necessary to calculate the inverse matrix in decryption. Number two, encryption method that combines ECC with Hill cipher. A new key matrix generation algorithm presented to enhance the resistance of the encryption method against some plain text and non-plain text attacks. Key length is revised in order to improve resistance of the key against brute force attack. Number four, improved image encryption method that combines chaotic system and ECC. A new key stream is generated using chaotic system and mixed with a pseudo-random bit sequence that generates with elliptic curve points. Then the image is divided into 8 bits data and encrypted by XOR operations. Number five, method that encrypts the images using ECC. Image pixels are grouped according to prime number of ECC and converted into the big integers using from digits algorithm to enhance speed of encryption. To create the encrypted image, all bits are reduced to 0 to 255 range using integer digits algorithm. Number six, method that encrypts image with case sequences. Case sequences are created by using chaos-driven elliptic curve pseudo-random number generator. The case sequences are based on elliptic curve point operations with the chaotic map. Number seven, image encryption method using ECC with Hilbert matrices, 2 by 2 and 4 by 4 matrices that has inverse matrices are used as a secret key. So it will not be necessary to calculate the inverse matrix in the decryption process. Number 8, encryption method for large images. Large images are split to 256 by 256 sub-images. Then using key matrix generator algorithm, sub-images are converted to 256 by 256 key matrices. Next, it will be applied snake addition and modified Arnold map to the key matrices. Lastly, the image is encrypted using the key matrices with ECC. Number 9, image encryption method using ECC. A secret key is provided from the plain image using SHA 512. Then 4 chaotic sequences are generated using chaotic maps equations, which are LTM and TSM. Next, DNA sequence is generated from chaotic sequences. After permutation and algorithm encryption, the image is encrypted with DNA sequences. Number 10, improved encryption method using ECC and for the chaotic system. In order to improve resistance of the method against plain text and ciphertext attack, #256 codes have been used in plain image. These codes enable to share the generated point of ECC among the intended users without any loss or any fraud. Number 11, digital image encryption technique based on ECC. An elliptic curve is chosen for calculation of public and private keys. After iterations applied, a chaotic sequence is provided. Chaotic image is generated from this chaotic sequence. It generates big integer numbers from the chaotic image applying group pixels. The big integer numbers are encrypted using ECC. Number 12, image encryption method using Hanon-Map, dynamic S-boxes and ECC. The algorithm creates secure dynamic S-boxes based on Hanon-Map. Dynamic S-box is used to create an image encryption method which is resistant to chosen plain text and chosen ciphertext attacks. Because of some mix of security algorithms, the secret key is created by ECC in order to resist to several attacks. Conclusion: ECC is widely used in many applications thanks to its features such as short key size and low power consumption. Therefore, it is widely used in digital image encryption. Many parameters are examined when determining the quality of digital image encryption. Parameters such as entropy and PCR should provide optimal values in the encrypted image. ECC is quite suitable for image encryption. Hybrid algorithms such as chaotic systems, cipher key matrices, advanced encryption standards are used by combining different methods to make robust encryption algorithms with ECC. These are the references. Thank you for listening. Is there any question?
Thank you for your presentation.
Thank you.
Department, do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your career.
Thank you.
Dear Amer Muklif Hamad.
Yes, sir.
Okay.
So,
if you are ready, you can present.
Okay. Thanks. Just let me to share with you the presentation.
Okay.
Okay.
You have 10 minutes, please.
Okay, sir. I will. So, as you see, localization and identification of UAVs system using image processing. Here, this is the plan, the content of the presentation, introduction, related work, motivation, and the proposed system, experiment and result, finally, the conclusion. Here, the introduction. Unmanned aerial vehicles, UAVs, are widely used nowadays for photography, surveillance, mapping, and research purposes. These aircrafts control release on monitoring their location by constantly combining accelerometers, INS, with satellite communication. It is like GPS. The latter is usually referred to as localization, also a UAV navigator or navigation system that relies on GPS is vulnerable to signal failure. Also, such that is cloud be used as an alternative when the satellite navigator system modification and or be easily incorporation. Multi-rotors are one of the most widely used UAV platform by consumers and research due to unique qualities such as their vertical takeoff and loading VTOL capability, cost efficiency, and able to hover. The quadcopter became increasingly popular with researchers. It's partly due to increasing integration with other complementary technology. However, using the same search term and database as interest in aerial manipulation was found to have more than double to 4.6% as of November 2020. Here the proposed system. The main goal of the project is enable as UAV to identify its location with the camera mounted on it. Also, the system compares the image with a given orthophoto map. Also, the method presented here will generate it to find a relation between observation point above ground level. Also here, the map of the location that we will locate it. So due the need of using the algorithm of the video output, then by projecting the 4 corners, we will select it like here, okay? The algorithm solution consists of 3 major phases. First, it corrects the distorted frame, detected key points using ORB detected, as we see here of the algorithm as shown by, and calculates the found matrix. Here, in case of currently captured frame, as you shown by this algorithm, learning process, and telemetry function proposed. Here, the location database, screen database, and the learning process. Experimental result. In this study, we use Python software for experiment result. Python requires importing packages. Here we see one of the results that we used, that we shown by the Python of the quadcopter that we use. Also in this place, we will show in the points that we get by our result. As shown in table below, StarNet achieves the best localization accuracy of 28.4%, surprising the second best CSRNet. But also generates relativity more accuracy of localization of each object in SIST. Here, one of the photo that we get by our result. The conclusion here, the development of quadcopter system capable of localization, position, and heading. The development of the system was conducted using an empirical approach. Software design of the universal pilot adapter, and also the conceptual and detailed development of unexplained pilot for manipulating. Thank you for listening.